All right, everyone. So now I'm going to talk about a problem called clone a graph. If you want to know the best way to study for algorithms interview, take a look at the description that I've recorded a video that I tell the best steps to study for FANG companies. That's how I passed Microsoft. So without further ado, let's take a look at the problem called clone a graph. So this is I think it's a pretty cool problem because you need kind of a trick. So what you're gonna do is you're gonna use a dictionary, a hash map, to copy the elements over uh, to copy the nodes, and you're gonna connect all the copied nodes that are values to each other. This wasn't as clear as I wish it was, but I'm gonna show in the debugger and it's gonna become much clearer. So let's take a look over there. So we have a vertex, it has a label, so we can call it A, B, C. In this example, it's a pretty straightforward graph. I have A pointing to B and C, and then we call clone graph. So let's stop our breakpoint here, and you guys will see what I'm talking about. So right now I have a graph A, which has label B. B has no edges, label B, and C has no edges as well. So we have A pointing to B and C. So let's see how we clone. So we're gonna use Bradford Search. We're gonna use, always when you use Bradford Search, you use a queue. In Python, you use collections.dq that will create a queue for you. And we have a dictionary. So this is the core of the problem. We have a dictionary. The key is the original node. The value is the copy of the original node. So key is the original, value is the copy. Now we're going to use the Bradford search. So the first node in our queue will be, so we use pop left. So that's the function in Python to pop the stack. So right now, our node, our V is A. So we're gonna iterate over all the neighbors. First neighbor is B. We're gonna check if B is not in the dictionary. It's not, right? So only A is currently at the dictionary. And we're gonna create a key, which will be the original node, and a value, which will be the copy. And we're gonna append that to the queue. So now the queue has B, and this is interesting as well. So the dictionary V dot edges, so this basically grabs the edges of the copy of the original node. So the node we're iterating right now in the Bradford search is A. So we look into the edges of the copy of A and we append the copy of B. So you're basically connecting the copies with line 17. Now we go to C. So the neighbor is C. We're gonna do the same thing. C is not in the dictionary. We make sure we create a copy. We append that to the queue. And we append the copy of C to the edges of the copy of A, if that makes sense. So we're pretty much done because this is a simple graph. And so let's see if we actually can make sense of that. So if we look at the dictionary, we have, so this is B, this is C. So this is the value. So this is the copy of A, and it has as edges, the copy of B and the copy of C. So now we have cloned the graph, and all we have to do is return the copy of G. That's what line 18 does. And we have the copy of the original graph. So pretty cool problem that uses a hash map and a Bradford search. So I hope you guys enjoy, and any questions, let me know in the commentaries.